I'm Jake Newbold, and this is my ME305 final project called the automatic hot plate. The goal of this project is to maintain the heat output from this hot plate to keep the water boiling, but just barely, so that you're not putting in excess heat, because once you get water to boiling, it won't get any hotter when you put more heat in. So the goal is to save energy. So we'll start it by pushing A to input boil time, so the user is able to input how long they want the water to boil for once it gets to that temperature. I'm going to put in 10 minutes. Pound, and then asterisk to start. You'll see when I push this that it'll turn this motor, which turns the knob of this thing, which is regulates the voltage, AC voltage, between 0 and 120 volts going into the hot plate. You can stop the program at any time by pushing asterisk. It turns it back. The user then has to input again how long they want it to boil for. 10 minutes. Pound. Start. You see it turns it again. Turns the light on. And you see that it will display what the current water temperature is, as well as what the desired is. And we know what the desired is because of this thing. Barometric pressure sensor. At the start of the code or program, it reads the pressure and then determines what the boiling temperature is by interpolating between data points that I put in there. We know what the current water temperature is because of this thermocouple connected to the Arduino inside there. The other components include the LCD display, of course, the keypad, and the stepper motor. There's a stepper motor driver there, and of course the tank. And I'll go ahead and pause right there because we just need to wait for it to get to boiling temperature, and that'll take a bit. You can see that the water temperature is rising. Sometimes it fluctuates a little bit, the pressure or the temperature reading. I have the program set to start the countdown timer when the temperature gets within 1.5 degrees of the desired. I'm going to show you when I get to that point. You can see that we are now within the 1.5 degrees, and it will periodically display what the time is left on the timer. 10 minutes. And you see the water is practically boiling, and I'll get back to you in a second. You can see that the minutes left has dropped down to 9, and I'm going to demonstrate real quick that if I dump in some water just to lower the water temperature so that it is no longer boiling, see that it has dropped down. It is no longer displaying the timer, and it will reset the timer when it gets back to boiling temperature. See, we are back within the 1.5 degree range, and it is reset the timer back to 10 seconds. Alright, you can see that so one of the pressure sensors, either the thermocouple overestimates the temperature or the pressure sensor underestimates the pressure, giving us a lower pressure point. But you can see that our actual temperature can get above the desired, but that makes it easier to control. You can see when we're over, the motor driver there is telling the motor to slowly turn to the left. You can kind of see it, and it is doing so to bring down the temperature, and it does a pretty good job at regulating the temperature. I found that it has to turn it down less the more water is in there, because it needs to dump in more heat to keep all of that water boiling. But the PI control does a pretty good job. And I do only have PI control. I don't have the derivative part because the pressure reading or the temperature reading is so jumpy that the derivative control would not do any good. So the PI control does well enough to regulate the temperature to keep it that desired, and you can see that the water is boiling pretty well. Yeah, we'll get back to you. You can see that the timer is getting pretty low, and once it gets, so it actually just turned off. And I just wanted to show you that when the timer goes to 0, it turns the motor back so that there's no more voltage going in, the light is off, and it resets the program and asks for user input again. and that is the hot plate.